Okay, so I had a student ask this question. So we're balancing this in basic conditions. So just to remind you of what our basic conditions are, I'll throw this out. We have kind of a list here, and you can take a screenshot if you want to, or go back to your notes. But we first split everything in half reaction. We're going to balance any oxygens with water, or we're going to balance the water with an H+. And then however many H pluses we add, we're going to add OH minus to each side. Then we cancel out any OH and H plus together, making them water. We balance the electrons, so they all have the same charge. Then we balance the half reactions, so they have the same number of electrons, and add them back together. That's a whole lot of words. Let's instead do some work. All right, so starting with these two half reactions. So here we have that, and we have that as our two half reactions. This went from a negative to a positive. This iodide was oxidized. And this manganese was reduced. Over here it looks like it was a positive 8. So let's do it anyways, because it's kind of fun. So the total was -1. We know that we had -8 from each oxygen, so we know this had to be +7. So manganese was +7, it went down to +2. In other words, it was reduced. All right, so let's take those two half reactions. Let's start with the I. Sweet. Okay, so first things first, I see that there's two I's over here and only one, so we need to add an I over there. So it's II. All right, now we have a negative, but we have two of them, so we have to add 2 electrons to this side. As far as we're concerned, this half reaction is balanced like that right now. It's this one with the oxygens that should make us pause. And remember that when we're balancing things with oxygen in it, we're generally going to see if it's acidic or basic conditions. Okay, step number 1, if you remember, was to balance with water. Okay, so when I'm balancing this with water, over here I have 4 oxygens, so that means I need to add +4 water. And because this is complex, I'm going to get a different color marker if I can find one. If you have kids, you know finding a marker that actually works is kind of frustrating. Okay, so we added that. We'll just do this. Okay, so step number 2. Once we've balanced with that, we've added H+, so 2, add H+. So if I were to write this whole thing again, we're going to add H+. Because we added a total of 8 hydrogens, we're going to add 8 H+. Cool. All right, number 3, add OH minus for every H+, but on both sides. Okay, what I mean by that is over here we had 8 H pluses, so we're actually going to add 8 OH minuses. But I don't say do it to just this side, I say do it to both sides, and the reason for that is to cancel things out so you don't introduce new elements, so it stays balanced. All right, cool beans. So we added that, we added that. All right, step number 5, or 4. We're going to put H+ and OH minus together. Because H+ plus OH minus equals a water. So this one and that one, for every OH minus, we have an H+, that equals 1 water. So we have 8 OH minuses, 8 OH plus another plus. In other words, we have 8 H2O. now 5, we can add electrons. Okay, so if we total up the charge over here, we have a total of -1, right? We have 0 from the water plus -1 from that sucker. And then over here, we have +2 plus a -8 for a total of +6. We have to add, hold on, I screwed up somewhere. I can do this. -8 plus +2 is -6. I can do it again. Cool. Okay, so now when we go to, so over here I have -1, over here I have -6, and what that tells me is I need to add -5 in order to get -6 on both sides. You're always adding the electrons to the more positive side. Okay, so I'm going to say 5 electrons plus 8 waters plus MnO4 negative, yielding Mn2 plus 4H2O plus 8 OH minuses. All right, and this is the one that I added. Now we were almost ready to add these up. Almost. Oops. But then we see that this has 2 electrons and this has 5 electrons, and we know they have to have equal number of electrons before you can add them up. So we're gonna have to multiply this whole thing times 2 and this whole thing times 5. It's the only way you can get them to cancel is to find that lowest common factor. So total of -10, total of -10 over here, and that way our 10 electrons on either side can cancel. So let's go ahead and rewrite them. Again, we're multiplying this whole one by 2 and this whole one by 5. Let's start with this one by 5. That would give us 10 I minus, yielding 5 I2 plus 10 electrons. All right, now we move on to this one. We're multiplying it by 2. We have 10 electrons, that's good news, plus 16 waters plus 2 permanganates, all yielding 2 Mn2 plus, 8 waters, and 16 OH minuses. Just like we talked about in the lecture, you can cancel these waters at any given time. Now is probably getting close to a good time, but I'm just going to be consistent and add them all in there. All right, when we go to add these two reactions up, we have 10 electrons here and 10 electrons there, so those are going to cancel. Now let's add them up. I'm going to start with 10 I minus plus 16 H2O plus 2 MnO4 negative, all yielding 2 Mn2 plus 8 H2O plus 16 OH minus plus 5 I2. Okay, right now this should be balanced, but I do see that I have 16 waters over here and 8 over here. So essentially 8 of these waters are going to cancel out. So I'm going to cancel out these 8, and I'm going to cancel out 8 on this side, which will just leave us with an additional 8 over there. Because 16 minus 8 is 8. And now we have 10I minus plus 8 H2O plus 2 MnO4 negative, yielding 2 Mn2 plus 16 OH minus plus 5 I2. Awesome. Now let's do our last check and make sure everything adds up. Over here I have -10 plus 2 times a -1 for a total of -12. And on this side, I have a +4 because I have 2 of these, plus a -16, 16 times OH minus, for a total of -12 on this side as well. So I'm good. This reaction is my final answer. All right, I hope that helps.